Yes. Anyone?
ANOVA is a more robust hypothesis testing tools than t-test.
Mm-hmm.
Where in t-test we can compare two, but in
Mm-hmm.
case of ANOVA we can compare more than two. Here
Very
also we are comparing the mean difference in the mean.
good. Thank you. Very correct. So we can say it is a parametric test, first thing, right? Because it is considering the parameters of the population like mean, standard deviation, etc. Right? Apart from that, help us for the hypothesis testing. And the hypothesis, which kind of hypothesis it is helping us to test? Just
H0 null hypothesis.
yeah, H0, the nature will be significant difference kind of. So wherever we are interested to find the significant mean difference, I must say, significant mean difference, there we are using the ANOVA, right? But then there is a resemblance in ANOVA and T because T is also doing the same thing, that is finding the significant mean difference. So for differentiating between ANOVA and T, we can say here we need to have, or we are comparing the mean in more than two groups, right? So that means T is only limited till up to two groups. So not more than two groups we can use t-test. If we are having more than two groups available to us, priorly we need to decide in which two groups we want to find the mean difference, right? So ANOVA is a test which can help you to compare the mean simultaneously in all the groups. So when you want to compare mean in more than two groups simultaneously, we are using ANOVA, right? So here, but there is one more limitation when you are talking about ANOVA. ANOVA limitation is what? Usually when we are making the hypothesis, we are writing the null hypothesis will be mu1 equals to mu2 equals to suppose up to mu n. Whatever number of groups we are having, we are writing mu1, mu2, mu3, mu4 up to mu n, right? This is the null hypothesis. But when we talk about the alternative hypothesis of the ANOVA, we are saying at least one of the mu is different. Meaning is what? Meaning is what?
It means that it doesn't signifies which column has the difference in the mean, but any of them can have the difference in the mean.
Yes.
For knowing further, we need to perform a post-hoc study.
Yes. So we are suppose we have three groups, right? So if alternative hypothesis is supported by the data, that means we will say at least, not least, at least one of the mu will be different. That means it might be possible that group 1 and group 2 is differing. Maybe group 2 and group 3 mean are differing, or maybe group 1 and group 3 mean are differing, or maybe in all the three groups there can be a difference in the mean. So this is the kind of limitation which the ANOVA is presenting before us. It is only helping you to say this thing, that there is a significant difference, but in which group that difference is existing, whether in one group, two group, three group, or in all the groups, that you cannot comment using the output of ANOVA. I hope you are getting said.
Yes, ma'am. That's why it is called omnibus test.
Yes. Anyone else who is having any query what I have said just now? Is it clear to everyone?
Ma'am, could you please paste that from day 8 to till this point in chat box?
Okay.
Then we can read it properly. Thank you.
Fine. So moving ahead, now talking about, I hope till here whatever I said, it is clear to everyone now. May I proceed?
Yes, ma'am.
Yeah. So now we will see one more thing. When we are saying it as ANOVA, analysis of variance, meaning is that we want to compare the variance in the mean of various groups, right? That is why we are calling it as a analysis of variance test, right? Now we will see the types. So as there is one way ANOVA, everyone knows this, and there is two-way ANOVA, right? So in case of one-way ANOVA, variables will be DV, continuous, and IV, categorical, with more than two groups, right? So this is a case of one-way ANOVA. So, for example, we want to compare the marks of students belonging to three sections, right? So in this case, can anyone tell me which will be the independent, which will be the dependent variable in this example?
DV is the marks and IV is the sections.
Done. So I hope one-way ANOVA is simpler to understand. Here we will say there is no significant difference in the mean marks of students belonging to three sections, right? Clear?
Wait a moment, madam. You
Yeah.
just see. Wait a moment. Can you please repeat again that
Hypothesis?
the marks and section, their relationship in the one-way ANOVA?
I said there is no significant difference in the mean
Okay.
marks of students belonging to three sections. Done? Done? Sir, done. Shall I proceed?
I'm just typing, ma'am. Just you
Okay.
proceed.
Okay.
Just
Okay. Done? Typing done, sir. Once you are ready, please tell me so that I can proceed.
Ma'am, better way you just copy paste again. Then it is
I
better.
have not written the hypothesis, sir. Sir, I have not written the hypothesis. I have just communicated. There is no significant
Yeah.
difference.
No. The notes that bullet that you are typing in that comments, these comments are helpful us. So if you paste that, then we will get the idea exactly what we get, what you see. It's reduce our time. Otherwise, if it will take time to type, see it, because just watch and type take too much time. Yes, sir.
Okay.
Thank you. Thank you.
Now, okay, fine. So now we are talking about two-way ANOVA. One-way ANOVA is clear. So in two-way ANOVA, again, purpose is to compare the means, right? But in two-way ANOVA, we will be having the two-way type of table. Two-way type of table meaning is that we will be having total 3 variables, right? So here variables will be DV and 2 IVs, right? So DV will be the numeric variable and IV will be the categorical variables like the one-way ANOVA. So we need to have only one dependent variable and 2 independent variables. Is it clear? Is it clear?
Yes, ma'am.
For example,
Please repeat.
comparing. Sorry,
Uh, can you repeat, please?
from where?
That two-way ANOVA.
Okay, I said two-way
Some
ANOVA. I said two-way ANOVA means two-way analysis of variance where we are comparing the mean in 2 ways. 2 ways means row-wise also and column-wise also. So we will be having one variable that is categorical in the row and second variable categorical in the column, right? So that way we are requiring total 3 variables, 2 independent, that is categorical variables, and 1 dependent variable, right? So suppose I'm saying comparing the marks of students on the basis of sections and gender. So what will be the variables here, anyone? Except Mayuri ma'am this time. Anyone else? Anyone else? Please tell me.
Madam, variables are that marks, sections, and the student's name or students.
No. I'm asking which will be the dependent, which will be the independent variable here.
Okay. So here,
and section and gender as the independent variable, and marks of the students is a basically the outcome, it's a dependent variable.
Very good. Thank you, sir. Done? So in
Yeah,
this, so in this case, you need to see that how we will formulate the hypothesis. So in this case, total formulation of the hypothesis will be 3, right? So here we will make 3 null hypotheses. So 3 hypotheses will be like 1 for marks and sections, second will be for marks and gender, and third will be for marks and both the independent variables. So in this combinations, you need to prepare total 3 null hypotheses. Is it clear?
Yes, ma'am.
Fine. So I think theoretically it is enough to discuss. I'll now take you to the R and we'll see now how we can perform the ANOVA, right? So what I'll do today, in the same fashion the way I discussed yesterday, VT. So I will do through the what I can say this vectors, right? I will create vectors and then I'll explain you, and then I'll give you one empty cards. Means empty cards is already available in the environment of R. So with that, I'll give you some situations and then I'll ask you how to perform ANOVA there. Is it fine?
Yes, ma'am.
Yes, ma'am.
So I'll take here, suppose I want to compare the salaries of employees on the basis of their designation, right? This is the situation where I want to compare the salary of the employees on the basis of their designation. So salary is undoubtedly will be the numeric variable, that is dependent variable, right? And this designation will be the independent variable. So if in the designation we are taking more than 2 categories, then we are applying the ANOVA, right? So suppose I'm making my vector for designation first. So any three designation, suppose I'm taking accountant, I'm taking manager, and I'm taking clerk. Fine. Actually, this data I used previously also, but maybe it can vary in terms of counting. So I'll make the what I can I say I am making this vector. So you please wait, right? I'll post this in the chat. Fine, everyone.
Yes, ma'am. Fine.
Yes, ma'am.
So arbitrary any small figures I'm taking right now, right? So please don't mind. Obviously, these will not be the salaries, right? Or maybe these will be the salaries in the older times. Done. So you can take it from the chat and run, and then tell me if you are ready, then we'll proceed. Done.
Yes, ma'am.
Okay. Now, assumptions part I have not discussed above. So I'm taking assumptions here, and right after writing, we will check it here, right? So assumptions in case of 1 ANOVA will be the normality of the DV variable, right? You need to check the outliers in the DV, and you need to check one more thing here, homogeneity of variance, right? Usually in SPSS, we can call it as an equal variance. Done? Fine. Shall I proceed? Everyone ready?
Yes, ma'am.
Yes, ma'am.
Fine. So, I think yesterday we have discussed first two. So, anyone who can tell me how we can check the normality?
QQ norm
Hmm.
or QQ lines or
Yeah,
Shapiro test.
very good. So, firstly, I'm checking this, variable salary. I'm taking here inside the brackets of the Shapiro dot test and checking whether it is normally distributed or not. Done. Done. So, P value is
Yes, ma'am.
less than 0.05. Done.
Yes, ma'am.
So visualize, you can do visualization also of the normality for the salary variable, and you can see there is a large deviation in the data points and the fitted line, right? Fine, everyone. Once you people are done, ready, please tell me.
Yes, ma'am.
Okay, what about others? Everyone is ready?
Yes, ma'am.
Okay. So now we will check the outliers. For outliers, what is the function?
Box plot. Yeah.
Box plot. As the data size is very small, so the boxes you can see they are very thin. What means very thin means the only line kind of thing we can see here, right? So it is only because of the data is very small and very close, maybe. Getting me? But outlier you can find there is no outlier coming beyond the whiskers. So that way we can say in any category there is no outlier available, right? Neither in the accountant category, neither in the clerk category, neither in the manager category. Fine.
Yes, ma'am.
Fine.
Fine. Now for the next checking, which is related to the homogeneity of variance. Now you need to install a package. Name CAR. So you need to run both the lines. I already have this package, so I'm not installing it again. You can install this, means you can run this line and you can run the next line also. Then it may take few seconds. So once you people are ready, please tell me.
Done, ma'am.
Okay, what about others? Everyone is okay?
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Okay. So here I'm selecting the 11 test function and passing the name of the variable. Done? Done?
Ma'am, I got error.
Okay, what error are you getting, ma'am? Show me.
Uh,
You can share your screen.
yes, ma'am. Just a minute.
Okay. In place of this test, ma'am, right? I think there are two functions with the same name. So remove this period dot and
The
make
dot.
first T caps.
T cap.
Now run. Getting?
Okay, ma'am.
Fine. So shall I share my screen now?
Yes, ma'am.
Yes, ma'am.
Okay. Karthik sir, do you have any problem? I think you raised the hand.
Yes, ma'am.
Yes.
Getting the error, library card.
Okay. What is the error?
Just show you.
Are you sharing screen?
Yeah, ma'am.
Firstly, you need to install it, sir. Without installing, how you can call that library? You need to install. I think I have written one more line. Install.packages. Above this, enter one more line. Above, maybe somewhere, but you need to run this line first, and then you need to go to the library line, right? Getting me?
Sorry. Where?
Sorry.
Okay, okay.
Are you getting, sir?
Install.
Install.packages. From here also you can type CAR. Type CAR. This. Now install. Wait. All the dependencies will be uploaded. Please wait, sir. And then once you are getting that greater than symbol in the console, then you can run the line number 19.
Now can run?
No, wait. I think I cannot see the greater than symbol in the console, right?
Greater than. No.
So I think you need to wait, sir. Wait. It sometimes it takes time.
Okay.
Wait. Only single line it is coming. Something trying URL https result.com Windows.
No, there is number is different.
Okay, is it?
Sometimes LME/1 3.1.
Okay. Wait, sir. Unzipping should be done, no? All the dependencies should be loaded. Now it is working. Wait. Now run line number 19. Done. Now you need to run the function live in type in the come line number 20. Come on the line. So line number 20. Come here. New line. Yes, sir. Type live in LEVEN EVENE. Select the second one. Select the second one. Now pass the name, salary, the tilde symbol.
Which one?
The tilde symbol we are generally using. I think in box plot also you have used maybe if you have performed box plot. In your keyboard where it is 1 imprinted, before 1, from the shift key you need to take that symbol. Oh, I am saying in the keyboard after salary you need to type that symbol, sir. From the keyboard above the tab, the very first button. So shift and first button above the tab.
Shift tab.
Left side of 1. Your upper side keypad is there now. 1, 2, 3, 4. The first button.
Shift plus tilde, that is above tab. Above tab, the first button. Which shift key you need to take?
This one, no, ma'am?
Sir, just a minute. I am sending you in a chat.
You know the symbol on 2 number.
Yeah.
Sir, I have sent you in the chat box.
So
You take it from there and then you
so
explore
see
in
that
your
below
and then you can
left hand side of 2, 1 and after that 1.
from the chat you can take, sir, and after that you can explore in your keyboard. If you can access WhatsApp, this, I think you are joining your device from your device only in this meeting, no? So go to the chat, copy and paste after the salary. I have sent you the symbol in the chat.
After the salary. Okay.
I hope you got it.
All the things, ma'am?
Sorry?
All the things. Sure.
No, I didn't say to you to do this. What you are doing, sir? Why you are copying or allocating the vector to this particular function? I said go in the chat box of the meeting. There I have given you that symbol. So copy that symbol and paste after the salary. I hope my instructions are clear.
Hyphen or underscore, ma'am?
No, I just shared at 6:4.
Yes, ma'am. Hyphen is there. Underscore.
It is not hyphen. It is tilde.
Okay. Salary.
Sir, remove the bracket. This should come inside the bracket, this symbol. Yeah, after this type designation and then close the bracket. Type designation after the symbol, sir. Before the bracket, closing bracket, before the closing bracket, type designation. I think you have created designation, right? Or not? Sir, have you created these variables?
Yeah, designation.
Is there in your script? If it is, then run it.
Salary not found. Object
So
salary
you have
not
not
found.
created, sir. I have already pasted. You need to copy and paste these both the vectors you need to run and then you can come to this. So I think maybe something you have missed during the sessions. Okay, fine.
Yeah.
Yeah.
Okay.
My screen is visible.
Yes, ma'am.
Fine.
Yes, ma'am.
Yeah. Now you can
Yes.
see. Although I do not need to copy all this, but still I'm doing for you people. You can check what is the meaning of this. I'm telling you. Right. Now you can see limit s is always represented by capital letter F, right? Here you need to only pay attention on the probability value, which is this, right? So this is greater than 0.05. Yes or no? Fine, clear to everyone?
Yes, ma'am.
Yes, ma'am.
So if it is clear, that means I need to write the hypothesis here. So I'm writing the hypothesis of the Levin test, that is variance is equal, right? So there is no significant difference in the variance. If you remember for you, it's in the form of no, we can say there is no significant difference in the variance of the salary in the two groups, right? So according to the results, we need to hold this null hypothesis because p value is greater than 5%. So we will hold this null hypothesis. That means we will say variance is equal. And this is what we are looking for. Is it clear? Friends, it is clear.
Yes, ma'am. From
Madam,
my
please
side.
repeat. This one, please
From
repeat.
where?
This one, the explanation that you give, no, that regarding the Levin test.
I think I have written the hypothesis variance is equal. And according to the
Yeah.
p value, I think we know the thumb rule says if p value is greater than 5%, we need to hold the null hypothesis or we will accept the null hypothesis. So we are accepting it. So we will say variance is equal.
So hold and accept both are same.
Yes.
Okay. Thank
So
you.
I hope till here. Okay. Thank you, sir. It is till here. It is clear to everyone. Shall I go ahead?
Yes, ma'am.
Fine. So now you can see variance means we have checked all the three assumptions, right? Now we will go to perform ANOVA. Fine. So I hope
Ma'am,
I
1 minute, ma'am. What
Yeah,
is that 7 stands for?
degrees of freedom, ma'am. Almost
Okay,
like
ma'am.
ANOVA.
Okay, got it.
Yeah. So I hope I can go ahead.
Yes, ma'am.
Okay. I created one object here named as result. I'll use the function AOV, that is ANOVA, right? Here I need to pass the name of my both the vectors, separating them by the tilde. Done.
Ma'am, A is missing in salary. SALARY.
Thank you. Done.
Welcome.
So then I have run this line. I hope everyone has done this.
Yes,
Shall I
ma'am.
go ahead?
Yes, ma'am. Till done.
Done. Now, if you will run or call the result object, you can see you're not getting the sufficient information. It is not showing anything regarding the p-value and all, right? So you need to now use summary function, and then you need to pass the name of the object wherever you have stored the result. Getting?
Yes, ma'am.
Right. Now you can see these are your results. Right. According to this particular table, this is the source of variation. So those who have applied ANOVA using some other softwares or maybe have done ANOVA manually, they know the table which we are producing at the end or the output of ANOVA, in that the first column is the source of variation. I think someone has forgot to mute him or herself. Right. So now source of variation is 2, designation and the residual value. Degrees of freedom will be 2 and 7. Sum of square means it is like x minus x bar square, whatever we are generally finding when we are finding the standard deviation and all. So this is that sum of square. Then this is mean sum of square. So mean sum of square, generally how we can get this? When we are dividing the sum of square by its respective degrees of freedom. That means this value will be divided by the 2, you will get the mean square, right? Then the f value and the p value, right? So f value is nothing but this is the ratio of this mean square. So this, the big one divided by this one. Designation MSE divided by the residual MSE will give you the f value, right? And then we are getting the p value. So although we need to do the what I can say conclusion on the basis of the p value, which is 6.19 10 to the power minus 7, right? Which is very small. So here you can see the 3 stars. So 3 stars meaning is written here. That means at 0.001%, this ANOVA results are significant. Is it clear? Done, everyone? Done?
I'm here. P value is 0.001. It is right now? Is it right?
No. P value is this.
Okay.
And triple star meaning is that you can compare this with this also. Means you can say this thing that your p value is less than 0.001. Means at 0.001 also your p value is coming less than. So it is but obvious when it is less than to this, we can say it is less than 0.05 also. Right?
Okay, ma'am.
So I think we haven't made the null hypothesis. There is no significant difference in the mean salary of employees on the basis of designation. Done? This is the null hypothesis, which we are not accepting. So we can say there is a significant difference in the mean salary of the employees on the basis of the designation. Is it clear?
Yes, ma'am.
Okay. Now, when the significant difference is coming in the ANOVA, that means we can say at least one of the mu is different. Now, which mu is different, that is not known to us. So that is why we are applying here the multiple comparison test. Right? Fine.
Yes, ma'am.
You need to use the function called TUKEY, Tucky HSD. 2K also sometimes people are saying it. So up to you how you are pronouncing it. And then you need to pass the ANOVA results. So wherever you have stored the value of or results of ANOVA, that particular object you need to pass inside this particular function. So that way you can see in the console, it is giving you the pairwise comparison. So when I'm comparing the C with AC, means clerical staff salary with the accountant. So we can see the significant value is 0.03, which is less than 0.05. So we can say there is a significant difference in the salary of clerk and accountants, right? Then managers and accountants. So again, you can find the P value is very small. That means we can say there is a significant difference in the salaries of managers and the accountants. Then again, the last P value is less than 0.05. We will say there is a significant difference in the salaries of managers and clerks. Done. The pairwise comparison is clear.
Yes, ma'am.
Yes, ma'am.
Fine. So if it is done, I hope we can proceed for now two-way ANOVA.
Yes, ma'am.
Fine. Everyone is
Madam,
ready for
madam,
two-way ANOVA.
Actually, through some network problem. So can you repeat again the clarification of that multiple comparison?
Okay, in the console you can see we are having pairwise comparison and we are having three P values. So each P value is less than 0.05. So we will conclude there is a significant difference in the salaries of clerk and accountant, in the salaries of manager and accountant, and in the salaries of manager and clerks.
Okay. Yes. So we are comparing in between them, manager, clerk, and accountant.
So pairwise comparison we are doing now.
It is called as Tucky HSD result.
Sorry?
So the function that you are using, that is Tucky HSD.
TUK, you are 2K HSD.
2K. Okay, 2K HSD. Okay, madam. Thank you.
Ma'am, one thing, there is various post-hoc tests available. Why we use that particular QK HSD
I
or
think it is
simply
very famous. Actually, there is some logics which I am having somewhere. But logic generally people are, in most of the research papers, if you will find, this is generally most reliable and used. What I can say, the parameter. So people are generally using it. So generally, when the variance is equal, in that case, we are using 2K HSD. So in our case, variance was equal. So we have used 2K HSD, which is easily available in the R with this particular function name, right?
Yes, ma'am. Got it.
Yeah.
But one more confusion is there. When we test the variables, we find that the variable is not normally distributed. But we go with the ANOVA, right now.
Yeah. Actually, in our case, right now we have taken we have assumed the data only. This is the first thing, right? But usually, if in your research papers also your data is not normal, if you are testing, usually people are not testing when they are using sample size greater than 30. But still, if you are using it, right? So you can find generally ANOVA is a robust test for the normality, right? So if that kind of literature somewhere you are finding, so in the support of why you have applied this test, even when the data is not normally distributed, you can put in your research paper.
Got it, ma'am. Thank you.
Yeah. So I hope I can proceed now for two-way ANOVA.
Yes, ma'am.
Okay.
Madam, this output I didn't get the output that you have in console now after the execution of that command. That's the KHSD.
Share your screen, sir.
Please.
Sir, run line number 70. Line number 70 is a run.
Yes, I run 2-3 times, but it shows only that this one. Need to increase font, ma'am?
Come in the line number 70. Come Line number 70. Yes. Now run it. Run it. Press Control Enter or run. Okay. What are you getting?
Invalid
Invalid
argument
argument
to binary
to binary operator. I think spelling is correct. PUKE by HSD. When you have typed this particular function, it was showing in the prompt
Yes,
to
ma'am.
you.
Yes. I'm again one more attempt.
You select it.
Need to give inverted comma.
No, nothing. Do one thing.
Yes, ma'am.
Go up. Mm, up. Wherever the vectors are there, go to your vectors. Run vector, salary. Similarly, wherever is a designation, run that. Now come down. Come to the line number, just a minute, just 47. Run this. 47, have you run?
Yes, ma'am.
Then he has
Why
mentioned
it is showing you the
space.
result?
Space is salary, and it is showing space between the salary designation. It can be possible.
No, yeah, it is possible. No problem in that.
Shall I reduce the space?
No.
Remove the space?
Run line number 48 again, sir. I want to see. I think it is run. Yeah, no problem. You're getting. Just a minute. Wait. Come down. Come down.
49 number.
No, nothing. Come down. 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 Now run 71. So why your cursor is at line number 61? Come to the 71 directly, I said.
Still, it automatically goes to 61, ma'am.
Why it is going to 61?
Still, I don't know, ma'am.
Have you kept it is there. You have kept the hashtag everywhere, no? Wherever are the commands. This line number 64 is what? It is creating problem probably.
Yes, ma'am. Now that 64 line number
64
problem
was
is there, I
creating
think.
problem, yeah.
Yes. There is no comment. That's why.
Yeah, that is why it is showing you the same lines again and again.
I just copy from console and pasted for reference purpose.
I think rather than copying and pasting here, you can copy in your Word document also. Because sometimes it happens.
Yeah,
It may
simultaneously I
confuse
pasted there also.
Yeah.
Yes, ma'am. Thank you.
Yeah. Okay.
So
Sorry. My window is visible?
Yes, ma'am.
Yes, ma'am.
Okay. So now to save time, I will use the two older vectors which I already created. So that is why I think I do not need to type them. Along with this, I'll take one more variable, right? So this variable also I'm sharing with all of you, right? So you do not need to type. Please wait. Okay, I posted in the chat. You please check. Done? Done, everyone?
Yes, ma'am. We have done.
Done. So shall I proceed, everyone?
Yes, ma'am.
Fine. So I'm writing my first null hypothesis here. There is no significant difference in the mean salary of employees due to designation. Done? This is the first. Second will be, there is no significant difference in the mean salary of employees due to gender. Third will be, there is no significant difference in the mean salary of employees due to interaction effect of gender and designation. So these will be the total 3 null hypotheses in case of two-way ANOVA. Done? I am repeating again. There is no significant difference in mean salary due to designation, due to gender, and due to interaction effect of gender and salary. Means individually gender is not making any difference in the salary. Individually designation is not making difference in the salary. And then when you are combining designation and gender both, then it is not making difference in the salary. Clear?
Yes, ma'am.
So out of 3, first 2 are looking for the main effect because these are the single effect we are looking. So this is the individual effect.
Ma'am,
Yes.
please repeat third hypothesis one time.
I said there is no significant difference in mean salary of employees due to interaction effect of designation. So I think
Okay.
I have
Thank you,
copied
ma'am.
and pasted in the chat. Same way you can copy paste and replace the last letter, right? Done? Then second will be there is no significant difference in the mean salary of employees due to gender. And third, there is no significant difference in the mean salary of employees due to interaction effect of gender and designation. So that way you can say this thing that first 2 are the main or individual effect because single variable, single independent variable you are taking to see the difference in the salary. And in the last one, you are combining both. So you are looking for the interaction effect of both the independent variables. And then you want to see whether these are making any changes in the salary. Clear, everyone?
Ma'am, last one is what? Due to designation
Due to
and
gender.
gender, no?
Yes.
Combination of designation and gender, no?
Yes. So shall I go ahead with the assumptions?
Yes, ma'am.
Assumptions are similar, which we have talked about in case of one-way ANOVA, that is normality, outlier, and third one is homogeneity of variances. Done?
Ma'am, isn't it called homoscedasticity?
Yeah, you can call it. In regression, generally we are calling it. When we are talking about residuals variance, so generally we can say this thing. But here it is little different because when I say homogeneity of, means we are looking for the equality of variance.
Yes. Okay, ma'am. Got it.
Yeah. in heteroscedasticity, we are comparing both the things are similar or not, right? Similar in the sense pattern. Although
Yes,
similar
ma'am.
kind of thing, but here we are looking for the variance values are similar or not.
Yes, ma'am.
Yeah.
Done, ma'am.
Okay. Everyone, it is okay. Shall I start with the checking of the assumptions now?
Yes, ma'am.
Yes, ma'am.
Okay. So first one, I think I'm just repeating, although we have performed this already as we are taking the same variable. So you can see I'm not copying pasting. We are knowing this thing. Salary is not normally distributed. As we can say, the variable is very, the sample size is very low here in that case. So might be possible. So that is why we are not paying attention on this right now. For the demo purpose, we'll go ahead and we'll check the next thing. So I'm writing here remaining functions so that if you people are making your notes, this will be okay for you.
Ma'am, it is QQ norm now. You have written GG
Yeah,
norm.
yeah, it's keep to know. And done.
Yes, ma'am.
In the box plot, salary, and then gender plus designation. Gender. Done. Fine. So as again I am saying, don't look at the size of the box plot. Data is very, very small here, right? So that is why we are getting very thin kind of box plots here, right? That way you can check for every combination you are getting the box plot. A female accountant, female manager, female accountant, female, this will be the male accountant, right? This will be female clerk, male clerk, female manager, and the male manager. So might be possible there is single data points we are having for the female manager and the male accountant. Getting my point? We are looking at the box plot. We can see we are not getting any circles beyond the whiskers, so that way we can say there is no missing value available, right?
Ma'am, here you have
There is
run
no
twice
object
QQ
available.
norm.
Sorry.
You have run twice QQ norm. You have
Repeat.
mentioned line number 934 and 935.
Line number
934 and 935 both are same.
oh, it is QQ line.
Yes.
Done.
Okay, ma'am.
Okay.
Madam, in this box plot, at second vertical or second that column, you don't have the name, but in the box plot that I got, in that it have the name.
It is
That
because of size or something. See, now it is come,
okay.
right? It is because of size.
Okay, ma'am.
The area is small.
Okay. So MAC is there. Thank you.
Yeah, I told this is a female accountant, male accountant, female clerk, female manager, and male manager. Done.
Done, ma'am.
Yes, ma'am, done.
Now for homogeneity of variances, you need to use Levin test. What it is showing me? Okay. Then in both the cases, you can see we are getting the different, in both the cases, the p-value is greater than 0.05. That means what we can say that the salary is having the same variance in the gender also or in the designation also, right? Clear?
Yes, ma'am.
Friends, done?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
So shall I proceed?
Yes, ma'am.
Fine. So this way we have checked the assumptions. Now moving ahead and applying the two-way ANOVA. So I think I have stored my output in the result one object, right? Using the same function AOV, passing the name of the variables salary, tilde, gender, plus designation, plus gender, colon, designation. Done. So for the interaction, you need to write gender, colon, designation. I think there is one more possibility. I need to cross check. I think I haven't done that, but I think it is there. Yeah, in both way it will work. Either the asterisk star that you can put for the multiplication, or you can put the colon. Fine.
Okay, ma'am. Both.
Ma'am,
both.
can you please copy paste the last code?
Okay. See in the chat.
Yes, ma'am, got it.
Everyone, it is okay till here. Shall I proceed? Yes. Shall I go ahead?
Just a minute, ma'am.
Okay.
Yes, ma'am, done.
Everyone, it is okay. May I proceed?
Madam, could you
Yes,
please
ma'am.
explain that exact the combination that you write now here?
Hmm.
Salary, gender plus designation again plus gender.
So whatever the number, whatever the number of IBs you are having, you can separate them by the plus, right? So gender is separated by designation. That means this will help you to test your gender, salary first hypothesis, salary designation second hypothesis, and third is salary and these two. So these two will be coming together. So you can separate them by this interaction, right? So interaction will be shown by the either colon or by the star, that is asterisk or multiplication. Fine.
Okay. Yes. Yes.
Now, using the summary function, we will see the results. So in the bottom, you can find, just a minute. I think I have run, just a minute. I need to result one. Yeah. You can find, we are getting the three P values. First P value is less than 0.05. Second P value is less than 0.05, but the third one is greater than 0.05. So first value is significant at first star, 1 star meaning is that 5%, right? 1 star. 3 star meaning is that at 0.001%, it is significant. Getting me? 0.001 means 0.1% it is significant. But the third one is not significant. So what we can conclude, we can say there is an indivisible effect of both the independent variables on salary. But when you are combining them, so you are not finding the interaction effect. So that way you can make the hypothesis like, or you can conclude like there is a significant difference in the mean salary of employees on the basis of gender, also on the basis of gender, but there is no interaction effect of gender and designation on the salary. Clear? Everyone is okay.
Yes, ma'am.
Okay. Hoping you people have noted down the interpretations also.
Yes, ma'am.
Expecting everyone to note down the means you need to write down maybe in your Word document or maybe in your RSK, you need to write down the conclusions also. Out of 3, only 2 P values are significant. That way we can say that salary is having the significant difference because of gender and the designation. But when you are considering gender, means particular person, means female is a manager and male is a manager. So in that case, you are not finding the significant difference. Getting?
Yes, ma'am. Just repeat the last line alone, ma'am. Yes, ma'am.
Okay, I said when we are looking at the p values, out of 3, 2 p values are significant. That means we can say gender and designation is making the difference in the salary. Individually, when I'm considering the gender, it is giving us the difference in the salary. When I'm looking the designation, it is giving the difference in the salary. But when I'm combining gender and designation both, it is not making any impact on your salary, right? Means I'm saying female is a manager, male is a manager. That way I am not finding the significant difference in their salary. This is the meaning. I hope clear.
Yes, ma'am.
Okay, what about others?
Yes, ma'am.
Fine. So when we are getting the significant difference, we can see as in the gender we are having how many groups,
2,
and in the designation how many groups we are having?
3.
So for designation, whatever hypothesis we have made, there we have found there is a significant difference is existing, right? So now we will apply 2K
Ma'am,
HSB.
your screen is vanished.
Is it?
Ma'am, screen is not visible.
Just a minute, again sharing. Where is, yes, here I am. Now visible?
Yes, ma'am.
Yes, ma'am.
Now you can check. Done?
It's a long list, ma'am.
Yeah. So if you are getting, now you can see. I can say male accountant, female accountant salary is not significantly different, right? Female clerk, female accountant salary is not significantly different. Means it has made all the combinations, right? Then male clerk, female accountant, significant difference is not there. Female manager, female accountant, there is a significant difference. Then male manager, female accountant, there is a significant difference. Female clerk, male accountant, there is no significant difference. Male clerk, male accountant, there is no significant difference. Female manager, male accountant, there is a significant difference. Male manager, male accountant, there is a significant difference. Male clerk, female clerk, there is no significant difference. Female manager, female clerk, there is a significant difference. Male manager, female clerk, there is a significant difference. Female manager, male clerk, there is a significant difference. Male manager, male clerk, there is a significant difference. Male manager, female manager, there is no significant difference. Here?
Yes, ma'am.
Okay, what about others?
Yes, ma'am. Clear from my side.
Okay. Rest, everyone is okay, clear with what I said? Yes? Say yes or no, friends. It is clear to you or not?
Yes, ma'am.
Yes, ma'am. Yes.
Fine. Now,
Ma'am, you have stopped sharing again.
just a minute. I don't know what it is happening today. Now visible?
Yes, ma'am.
So I have written plot. I'm creating a plot. Done. This is the first plot we are getting. And this is the second plot. This is for the normality. And first one is for the variance. Done. Done.
Just a minute, ma'am.
Yes, ma'am.
Done, ma'am.
When I talk about normality, you can check the normality here, right? So there you can find there is little deviation, right? 8, the observation 8 and observation 7 you can find. So there is a problem. There is a deviation from the normality, right? Then talking about the residual. So you need to see the middle line. This middle line is generally 0 line, which I can say. We need to see the data point should be scattered, means what I can say, they should not form any particular form. Form means any particular shape you should not observe in this particular graph. Like shapes are like pen shape, maybe cone shape. These kind of shapes should not be there. And second thing is that your data point should be almost equally distributed above the 0 and below the 0. In that case, you can say the variance is maintained or homogeneity of variance is there. So using the output of the ANOVA 2, you can also comment on these two things, normality and the homogeneity of variances. Clear to everyone?
Yes, ma'am.
What about others? I hope it is clear.
Yes, ma'am.
Fine. So this is all from my side. Now I'll give you the task, right? So the task is using empty cars data set. Find I think it was in type. So I am giving these two things to you people in the chat. You can see the chat. Problem is there. Read it and tell me what you people are understanding with this.
Ma'am, first we need to check how many levels are there in the basis of transmission.
Fine.
If it is more than 2, then we'll go for ANOVA. The first one is one-way ANOVA and the second one is two-way ANOVA.
Okay. What about others? Are you people understanding what I have given to you? Everyone, please say.
Yes, ma'am, it is similar to like that. The salary derivation that we have done, similar to like that.
Okay.
Yes.
What about others? Sonali ma'am, Rama ma'am.
I'm sorry, ma'am. Got received a phone call, so muted, ma'am. Yes,
No
ma'am.
issues. You
Yes, ma'am.
please see the chat box and tell me it is clear to you what
Yes,
is
ma'am.
to be performed. Satish sir, clear to you. Kartik sir, it is clear to you. Remaining everyone, those who are maybe
We are just trying to adjust, ma'am, because exactly not completely understand, but just
Okay.
by just practicing, we are trying to understand.
Okay, fine. So, what about who are regularly interacting to me? I am knowing their names. So, I hope everyone is clear what I have given in the chat. Kartik sir is saying, okay, fine, good. What about others? Anita ma'am is saying, yes, very good. Thank you, ma'am. Then, anyone else who wants to comment? Because thing is that now it's a practical applicability of the things. So if you are understanding or understood whatever I discussed so far now, so looking at the problem now, you need to tell or understand this thing which particular test can be identified applied on this particular situation. So I think Mayuri ma'am said already, but I am expecting anyone else to say what you are understanding from the given problem.
Ma'am, are we done with the class? Because tomorrow I have an exam, so I need to
Oh,
leave.
okay, all the best. Yeah, I think we are done. I'm just concluding and then take the questions if there are any having there any questions, right? So
Okay,
that
ma'am.
way I'll
Thank
conclude.
you.
Thank you. All the best. Yes. Anyone else? Fine. So I'm expecting you people to perform, right? So I will not discuss how to perform. Maybe tomorrow I can ask you how you have performed and how you have achieved the given task, right?
Madam,
But expecting, yeah.
Miss, today's all the things that we are performing, all the operations that we, functions that we are using, apply on these designation, salary, gender. These same kinds of codes, same kinds of functions we have to apply on this empty car data set. ANOVA test is there, no?
You need to see, sir. Generally, significant difference is mentioned to either t-test or ANOVA. But I think I've told you when you need to go for the t-test, when you need to go for the ANOVA. So according to you need to check,
Okay.
right? And then you need to see what your data is saying to you. Whatever is the availability, accordingly you will decide which test is applied by you.
Actually, what happened, ma'am? After the 12th, means after the 12th science, math subject is not in contact with me. I just I'm doing the computer science of programming language. So that kind of mathematics is not in regular touch. General
But
time,
I
general
think it
time.
is not a mathematics, sir. It is only conceptual thing.
Yes,
You need
yes.
to
But
only see what variables are given and what are the types.
actually, ma'am, what I want to share that the terms, the things that you are using, na, just I'm just means quite far away from that. So I just want to contact with them and just want to try. Is
Okay,
that
fine.
like?
Fine, got it.
So it is quite difficult to me, but I will just try.
Okay, fine. Thank you.
Thank you.
Thank you, sir. What about others? I think if it is fine, may I conclude the session?
Yes, ma'am.
Okay.
Thank you, ma'am.
Yeah. So friends, today we discussed analysis of variance test using R. We have seen ANOVA is very similar to t-test. The difference comes when we are having more groups available, right? So T can compare only two groups, but when we want to compare more than two groups, we are going for the ANOVA. So ANOVA is having the variety like one-way ANOVA and two-way ANOVA. In one-way ANOVA, we will be having only two variables. One we will take as a dependent and other we will take as a independent. So dependent variable will be the numeric, independent variable will be the categorical and with the more than two groups, right? So that way simultaneously in all the groups you can compare the mean. So ANOVA is lacking where it is lacking when you want to say in which particular pair of group there is a significant difference is existing. So that is not communicated by ANOVA. So for that we are having one test available named as multiple comparison test. or post-hoc test, right? So that way, if your ANOVA results are coming, that you are concluding like there is a significant difference, only in that case you will proceed for the multiple comparison test. But if the null hypothesis is accepted, in that case you do not need to perform multiple comparison tests, right? Then we have seen the second variety, which is the two-way ANOVA. So in two-way ANOVA, we will see two-way. Two-way means row-wise also and column-wise also. So that is why we will be having two independent or two categorical variables in case of two-way ANOVA and one dependent variable. So for the purpose, for checking this particular combination, we need to formulate total 3 hypotheses. 2 hypotheses will be for the main effect or for the individual effect. So in the combination of dependent and independent variables, you will make 2 null hypotheses firstly, and then the third hypothesis will be for the combination of your both the independent variable with the dependent variable. So that means in the third hypothesis, we are looking for the combined effect or the interaction effect of both the independent variables on the dependent variable. So this is 3 null hypotheses we need to formulate. And then using the AOV function available in the R, we can easily perform ANOVA. And then to see the results of ANOVA, we need to use the summary function, right? And then for post hoc test, we are using 2K HSD test. So depending, means you need to check whether you need to perform 2K means pairwise comparison test or not. So it will be performed only when you are accepting the alternative, right? So I think this is about the what we discussed today. Now platform is open for questions and answers if you are having any. Else we will end the meeting for the day.
Ma'am, I want to say something.
Yeah.
The problem is given by you to us. In this problem, we have to apply two-way ANOVA in second problem. Problem 2.
I think I will not tell. So tomorrow I'll discuss, because this is the task I have given. I want you people to explore. You try to understand. I have summed up today's session. Yesterday's session also I have summed up. I'm expecting you to please carefully look at the problem, as it is a significant difference case. So either it will be a problem of T or it will be a problem of ANOVA, right?
Yes. Yes.
According to the variable availability, you can go, and I think you know, question mark empty cars you will write, you will see whatever the data is available, or you can run a STR structure function, and that way you can see the structure of empty cars, and then you decide which test you are going to apply, right?
Okay.
Right. Tomorrow,
Thank
if you are not getting, so tomorrow we'll discuss this.
Okay. Thank you, ma'am.
Thank you, ma'am.
Okay, thank you, ma'am.
Anita, ma'am, you want to say something?
No, ma'am. No, ma'am.
Yeah, fine. Okay, any other query? No query? So can we call off a meeting for the day?
Yes, ma'am. Thank you, ma'am.
Thank you. Okay, I think we are done. Thank you so much. Tomorrow we are meeting at the same time, right? So Yogi sir, we are done for the day. If you are available, we can close the meeting.
Thank you.
Thank you, everyone. Good night. Meeting tomorrow.